Welcome back, everyone. Let's go ahead and work out these three probability problems. So I hope you have been introduced to the different formulas for probabilities. So feel free to pause the video, work this question out on your own, and then you can come back to the video and look for the solution. Let me go ahead and show you how to do these problems. Okay, so for the very first example, suppose 80% of New Yorkers take a train, 35% New Yorkers take a bus, and 10% of New Yorkers do not take a train or bus when commuting to work or school. So for part A, we want to determine what portion of New Yorkers take both a train and a bus when commuting to work or school. Part B, we will determine what is the probability that a New Yorker who takes a bus also takes a train when commuting to school or work. Okay, so here's what I'm going to do. I'm going to define my event. Let's go ahead and use the variables. Let T stands for those who commute by train, and let B be the event that New Yorkers, those who take a bus to commute to work or school. So those are my events. Now let me go ahead and write down what's been given. So we know probability of those who take the train, probability of T, 80%. So let's write that 0.80. Then probability of those who take the bus is 35%. So that's 0.35. So I just converted these into probabilities. And we also know that the probability that it is 10% of New Yorkers who do not take train or bus when commuting to work or school. So we know that will be the probability, not T or not B, right? So that's the T or B complement. That is going to be 0.10. So using this information, we can draw a Venn diagram for ourselves and figure out what we're looking for in part A and B. So suppose that's our universal set. Here is the set T, and let's call this the set B. Okay, so now I'm going to put down this information first because this is T union B complement. So T union B, well, that's all of this. That's T union B, which means the complement is what's on the outside of the circles. That's the rectangle. So that is going to be the value of 0.10. Now, if I know that's 0.10, then I know by complement rule that the union, this portion has to be 0.9 because we know the complement formula. So we know that the probability of T union B will simply be, this is going to be 1 minus 0.10, which will be 0.90. So that is fixed. Well, now we can actually, using this formula, we can figure out what should be in the intersection. So we also know this formula. So you should remember that the probability of union of two events is simply the probability of the first event plus the probability of the second event minus the probability of their intersection. So once you know that formula, and since we're given this, this, and this, we can figure out the missing piece, and that will go on this portion of the Venn diagram. Let's go ahead and do that. Plug these in. So for T union B, we just figured that's 0.90. Probability of T that was given to us, that's 0.80. Probability of B, that's 0.35. And we're looking for probability of T intersect B. So algebraically, we can solve for it. We can move this term to this side of the equation by adding, and then we can move 0.9 this side of the equation by subtracting. So, which means the probability of T intersect B would be 0.80 plus 0.35 minus 0.90, which will give us a value of 0.25. All right, so that goes in the intersection. Now filling in rest of the Venn diagram is pretty straightforward. So we know that this is 0.25. So we know the probability of T is 0.80. So that means this circle has to add up to 0.80, including the intersection. That means 0.80 minus 0.25 will give you this portion of the Venn diagram, that's 0.55, because the sum of these two has to be 0.80. Then we also know this portion of the region, that should be 0.35. So that means the missing region should be 0.1 because This plus that is 0.35. All right, now that that's completed, now we can answer the question. So going back to the problem, part A, what portion of New Yorkers take both? So we want both train and bus when commuting. So we want just that part of the region. So we know for the first part, we're looking for, so if I were to just, let me put it right here. So we know for A, we want probability of T and B. That will be 0.25 as we computed by using the union formula or simply by looking at the Venn diagram. Now for the second part, we want to know what is the probability that a New Yorker who takes bus also takes train when commuting to work. So that means that's conditional. So this will be the probability of those who take bus. So bus is the given event, also take the train. So that is what we're looking for the second part of the problem. Let's go ahead and find that. So for part B, we want probability of T given B. That will be using the formula of the conditional probability. That's probability of T and B divided by probability of B. So probability of T and B, we know that's 0.25. Probability of B, well, that was given to us in the problem, 0.35, or that's simply the sum of these two regions. So if I put that on the denominator, I get 0.35. And then if you do the calculation, you'll get this about 0.7143. So something like that. It's approximately that number. Moving on to the second example on our list. For this problem, Emily wants to run tomorrow, but rain has been forecasted. If it rains tomorrow, the probability that she goes to run is 1/4. If it does not rain tomorrow, the probability that she goes to rain is 4/5. Suppose the probability of rain is 1/3, and then we'll answer part A and B. So before looking into part A and B, let's go ahead and draw a tree diagram for this since we're given conditions. For example, if it rains, the probability she will run is that. If it doesn't rain, the probability she'll run. So these are conditional event. Let's go ahead and draw a tree diagram based off this. Let's define two events. Let R A. So I'm going to use let's see. So I will use R for rain, and don't want to overuse R. Let's use P for run. So that's my event. So we're given the probability of rain. So I'm going to start off with that. So here's my start of the experiment. So rains or it doesn't rain. So the probability is going to rain, that's 1/3. So here on this path, I'm going to put 1/3. Doesn't rain, that's the complement. So this will be 1 minus 1/3, or this is 2/3. All right, now the conditional event, she will run or she doesn't run. So P or no P, or even if it doesn't rain, she will run or she wouldn't run. So those are my event as I defined it. So if it rains tomorrow, so we're in this part, the probability that she will go to run is 1/4. So this is going to be 1/4. So I'm going to go ahead and put that down here. This is 1/4. Then I know the complement has to be 3/4 because some of these two probabilities should be 1. Then the next part, we're given that if it does not rain tomorrow, so we're right here, the probability she goes to run, so that's right here, is 4/5. So this is going to be 4/5, which means the complement has to be 1/5. All right, so that completes the tree diagram based on the problem. Now for part A, we want to know, find the probability that Emily goes to run in the rain tomorrow. So she will run in the rain. So we're looking at this path. We'll multiply these probabilities. So this will simply be the probability of R and P. So this will be 1/3 times 1/4, which will be about 1/12. So you can leave it in fraction, or if you want to put down the decimal, this will be about 0.0833. All right, so that is for part A. Now for the second part, we want to know what are the odds that the Emily goes for a run tomorrow. So odds for the event that she goes to run. So run is represented by P. So we're interested in this branch and also this branch. So to find the odds, you have to remember the odds for an event. So this is for rain. This is going to be probability of rain with comparison with probability of not rain. So, or you can simply use the formula. This is 1 minus probability of P, P meaning rain. Sorry, I'm using P for a run and then P is probability. So I hope you didn't get confused by that notation. Feel free to use another variable if P is confusing you. But that's what we're looking for, the odds. So the probability of run. So for this is going to be, so I'm going to find probability of run. That's going to be the first branch. That will be the probability of R and P plus the probability of not R and P. So looking at this branch plus this branch. So that's branch 1 and 3. So let's put down the numbers. This will be 1/3 times 1/4 plus this will be 2/3 times 4/5. And then if you put these in your calculator, you'll have this will be 1/12 plus this will be 8/15, which will give you about 37/60. All right, so that's for probability of run. Now, what's the probability of the complement? So the complement will be 1 minus so the probability of P complement, that's going to be probability of 1 minus P, which will be 1 minus 37/60. So that would be about, let's see. So if I do the subtraction, this will give me about 23/60. All right, now we're ready to set down our odds. The odds are comparison with this with that. So if I put that right here in my formula, so odds for P will be 37/60 over 23/60. By simplifying, this will be 37/23, which means the odds that she will run, I think that's what I was asking, right? The odds that Emily goes for a run tomorrow will be 37/23. That's how you will express the odds. Right, on to our last example of this video. A car dealership that sells both new and used cars has 3 salespeople, Alexander, Brianna, and Christine. 28% of all cars are sold by Alexander, and 38% of the cars sold by Alexander are new. Then we have 23% sold by Brianna, 86% of the sold by Brianna are new, and then 49% are sold by Christine, and 17% of the cars sold by Christine are new. So if a customer purchased a new car from this dealership, what is the probability that Brianna sold them the car? Okay, so another very good example of drawing a tree diagram. So let me go ahead and define my event. So here I'm going to use I guess I'll use the first letter of these cell people's name. So I'll let A stands for Alexander. Then I'm going to use the event B, for those who are sold by Brianna. And I'm going to use C for Christine. And also we have new and old. So I guess I'm also going to use the event N for new cars that are sold by these people. And of course, new complement will be old. So let's draw a tree diagram. So we have 3 salespeople. So we have 3 paths like this. Let me go ahead and make it straight. Okay, so here sold by either Alexander or Brianna or Christine. So 28% of the cars are sold by Alexander. That will be 0.28. That's the probability. Then 23% are sold by Brianna. This will be 0.23. Then we have 49% sold by Christine. So this will be 0.49. And you should check that sum of all of these 3 probabilities is 1. Now, within these salespeople, we have they're selling new cars or old cars. So here, Alexander selling new car or not new car, old car. So we know 38% of the cars are sold by Alex are new, which means that I'm going to put down so car that are sold by Alex and new. So that's this branch right here. So this is going to be 0.38. So if I do 1 minus 0.38, I get the complement, which is 0.62. That's not new, old car sold by Alex. Then we have Brianna selling new cars or not new cars. So Brianna sold 86% new cars. So we know that that's gonna go right here. This is gonna be the a segment for 86% new cars sold by Brianna. So if I do 1 minus 0.86, that will give me the 0.14 that are old cars sold by Brianna. Then the last path we have is for Christine selling new cars or not new cars. So for Christine, we have 17% sold by Christine that are new. So we'll put 0.17 here. That means the other path will be 1 minus 0.17. This will give us about 0.83. All right, so that completes our tree diagram. I hope this is making sense. Now let's go ahead and set up the probability that we're looking for. So if a customer purchased a new car and all right, so if a customer purchased a new car from this dealership, what is the probability Brianna sold to them? So if you think about this, this is also conditional probability. So we want to know the following probability. Probability, so it's conditional. So if a customer purchases a new car, so this is the new car, and we want to know what's the probability Brianna sold them. So Brianna goes over there. That is what we're looking for. Then we set up our probability, conditional probability formula for this. So we know this is equal to probability of B and N divided by probability of N. So that's Bayes theorem. As you can see, this is Bayes theorem. So B and N, the probability of that's gonna be this branch right here. So we are interested in this path. That will be our numerator. So we have 0.23 times 0.86. Now the denominator will have probability of N, new car. That's the event that takes place here. So let me highlight in different color. Here, here, here. So it's the probability of new cars. Doesn't matter who sold it. So we want this entire path plus this entire path plus this entire path. That's the denominator, and that is Bayes theorem. So we have our branch 1, which is from here to here. Branch 3 is this one. Then branch 5 is that one. So hopefully you have been introduced to that idea. So we have 0.28 times, sorry, I'm sliding up and down, times 0.38. That's the first branch. Now the third branch, we already had it in our numerator. So I'm just going to go ahead and copy that down here. And then the last branch for new, it's going to be branch number 5, this one right here. So we have 0.49 times 0.17. So that's the collection of these two. All right, that is our setup for this problem. And then if you put all of this in your calculator, you will get, so let me see. So if you put all of this in your calculator very carefully, you'll have about 0.5105. So that's the probability that the customer that purchased a new car from this dealership is sold by Brianna. That is the answer. All right, so we took care of different areas of probabilities. I hope this makes sense. There are a few more videos related to this topic listed in the description box. Feel free to check them out.